All right, so we are going to go over activities 10 and 11 in science today. 10 is mostly just reading, and we're going to watch some of the videos to help us really get a grasp and a good understanding of some of the vocab words that we've been using. And then when we get to activity 11, that's the one that actually has some things that you're going to do. So again, I don't want you going split screen on me. I don't want you, putting me in the background and having yours up in front of you. I want you just watching my screen and following along with me right now. So properties of matter, it says read the text, then highlight, we're not highlighting, any property that you did not measure in activity 9. Go back to the data you collected in activity 9, add what you've learned from this text to your descriptions. We're not going to go back to activity 9 and worry about changing anything, but we are going to go through this and look at some of these things. So the first thing though, the vocab word property. I know we've talked lots about properties, but let's watch a couple of these little videos that help us describe properties. This first one, remember, is just an animation. There's not talking to it. So a property could be that something is hard. It could be the mass, how much it weighs. A property is if it's rigid, meaning it doesn't like slack or like fall down in the middle. It's nice and solid. So those are some different properties objects can have. Let's watch this video on properties.
Although Earth scientists have identified more than 4,000 minerals, about 30 are the most common and form most of Earth's rocks. For example, granite is made up of the common minerals quartz and feldspar, along with mica and some specks of darker minerals such as biotite mica. Basalt is composed of the minerals feldspar and pyroxene, along with some olivine. Minerals can be classified several ways. One is by physical properties, the things you can see. These include color. Red, brown, brilliant blue, green, purple, and white are just a few shades found in minerals. Luster, the way light is reflected from the mineral's surface. Waxy, metallic, earthy, and vitreous are all words used to describe luster. Hardness, whether a mineral resists scratching, will scratch, or can be scratched by another mineral. Specific gravity, a measure of the density of a substance. Specific gravity is determined by comparing the weight of a mineral with the weight of an equal volume of water. Crystal shape is another physical property used for identification and classification. Crystals form when liquid rock from within Earth cools and hardens. The shape and structure of the crystal reflects the pattern or arrangement of atoms and molecules found within the mineral. Crystals are divided into 6 patterns, ranging from simple cubic shapes to complex multi-sided shapes.
All right, so they just listed several properties. Most of their properties, well, all the properties that they talked about were more related to minerals, to rocks, and things like that. But those properties also apply to, other things like color and shape and luster and hardness and mass. We can apply those to all kinds of objects, not just minerals, okay? Let's keep going. So back here, can I have a volunteer read that first paragraph?
Matter also has many properties that you can describe. Color, shape, odor, and texture are examples of physical properties that you can observe with your 5 senses. You can use words such as rough, blue, smelly, round, and sweet to describe these properties.
Awesome. We've watched that matter video a couple of times already, so we're not going to watch it together. But like you want to, you're more than welcome to go back and watch it on your own when it is time for you to log in and do these activities. Hazel, you want to read that second paragraph for us?
Okay. The ability to burn and the ability to rest are properties that describe how matter interacts with another matter. These are called chemical properties. An important feature of chemical properties is that they're durable by changing the material. For example, a chemical property of paper is that it is flammable. When paper is lit on fire, it becomes ash.
Awesome. So material, that's another one of our vocab words. Let's check that one out. Oh, maybe I didn't do material. Nope, we're not going to check it out. You guys can check it out on your own. Well, hang on. Or did I put it? Let me click through these, make sure. Oh, there it is. Material. So wood is an example of a material. You can shave it down to make it smaller. You can paint it, but it's still the same wood, right? You're changing the way it looks, but you're not changing its general properties.
It's time for Before You Know It, when we step across the cutting edge of technology and glance into the future of invention. We sent students to Wired Magazine's Next Fest in New York City to witness and experience some emerging technologies for themselves. At Next Fest, companies showcase technologies that are transforming our world. Today, we are looking into the future of materials.
What we have made is cardboard furniture. It's totally recyclable, lightweight. You can actually put up project tables in a matter of minutes, stand by and take it up once your project is done. You can paint on it, you can draw on it, you can make collage with it. It's rather inexpensive. It's lightweight. It's made up by a honeycomb structure. Because of the way the core holds between the two boards, this material can stand a lot of weight.
We also learned about a quieter, more efficient jet engine that incorporates new materials called composites.
This is a composite family for our G90 engine, which is a commercial engine that goes on the Boeing 777s. And the unique feature about this blade is that it's made from composite materials, and it's the first composite blade that's ever been put into use on commercial aircraft. I don't know if you know anything about composites and how they work. But composites are all fibers, and there's layer upon layer of the fiber materials, and it's like a fabric where they're woven, and there's layer over layer over layer that they keep building. But the nice thing about these composite materials is the durability. It's stronger than metal, which are traditional materials that we make fan blades from.
These new fan blades and the lighter fan pieces, will they support bigger planes?
This engine right here actually supports a bigger plane. It supports about a 200 to 300 passenger, but in the future, I think the sky's the limit in terms of what we can do with that.
That concludes this edition of Before You Know It. I'm Bill Nye. It will be time for our next edition, Before You Know It.
All right, so that was just a good video that went through. Oh,
Without great inventions and materials, we'd never be able to...
how long is this? Oh, he's almost done. Let me go back, let him finish.
Experience the joys of a monster truck rally. Rubber, glass, steel, plastic, and aluminum put to the ultimate test.
Bill Nye's awesome. I love Bill Nye's videos. All right, so he was just going through and sharing, they were sharing different materials and new materials and how materials can be used in new ways. Cardboard furniture, that seemed pretty interesting to me. I don't know. Probably wouldn't want to use it outside where it's going to get all wet when it rains and everything. Morgan, I saw your hand was up. Do you want to read the next paragraph for us?
Yeah. Volume, mass, and temperature are properties of that you can measure. Volume is the amount of space that matter takes up. Scientists measure volume in liters, milliliters, or cubic centimeters. 1 liter equals 1,000 milliliters or 1,000 cubic centimeters. A big bottle of soda that you might buy for a party typically holds 2 liters.
Okay, good. So volume a lot of times is used to measure liquid. because we would normally use like a graduated cylinder or a beaker, like a glass container, to measure the volume. So I could look at my Dutch Brothers drink here, and I could figure out the volume of liquid that's in it. So volume is normally for liquid, how much liquid is in a container. And it's measured in liters. And some of those conversions you guys should be familiar with from 4th grade, because 4th grade we, talk about the metric system and going from liters to milliliters. When you go to the store and buy the bottles of soda, that big bottle of soda that you get at the store is a 2-liter bottle, just to give you an idea of size. Do you have a question, Hazel? No? Okay. Let's go ahead and watch our little mass video, and then we're going to talk about mass next. Nope, that's measure. See, I thought I had them all in order. What's that one? That one's material. There's mass. We were at school, we'd be having these balances out and using them. So you put a penny on one side, and then you have grams. And they could be 1 gram, it could be 5 grams, it could be 10 grams, but you're trying to get it balanced so both sides are equal. So that's how you figure out how much it weighs. When that white arrow in the middle points to the middle part on that black scale there, that's how you know that it's balanced. And so in this picture, the book, it has more mass because it has more matter. It's heavier. It has more mass than the shell. No, the penny, not the shell. All right, kind of looks like a shell. Let's go ahead and play this one.
All matter has mass. What is mass? Mass is the amount of material.
Oh.
An elephant, for example, has more mass than a bee. And even though this brick and this box are the same size, the brick has more mass. The mass of any object can be measured. The unit used to measure mass is called the gram. 1 gram is a small amount of mass. For example, 2 paper clips have a mass of about 1 gram. A nickel has a mass of about 5 grams. A baseball has a mass of about 150 grams.
All right. So, hang on just a second. Let's go back and keep going. Do I have a volunteer to read to us now about mass? Someone who hasn't read yet.
Mass is a measure of an amount of matter. Scientists often measure mass in grams or kilograms. A dollar bill has mass about 1 gram, or 1 kilogram is equal to 1,000 grams. 1 liter of water has a mass of 1 kilogram.
Awesome. So remember, our volume is measured in liters. Our mass is measured in grams. And we're going to talk about this later in the school year too during math time. So little intro to it now. All right, somebody read me that last paragraph. Somebody who has not read. I can wait as long as you guys can. We need someone to read the next paragraph.
Recall that matter is made up of particles in motion. Temperature is a measure of how quickly the particles in a substance are moving. Quickly moving particles can give off more heat energy than slower moving particles.
Good. So all of these things are made up of particles, and the particles are in each substance. Let's take a look at what substance is. First, our fabulous animation. So solid, the molecules, we've talked about this, are tight packed together. There's not a lot of movements. In a liquid substance, the particles are a little more loosely packed, so there's some freedom to the movement. And then think about what a gas is going to look like. In a gas, they're really spread out. So there's lots of room for those particles in that substance to move freely around. A substance can be a solid, it can be a liquid, it can be a gas, it doesn't matter. Or a plasma. There you go, Spencer. It can be plasma also. All of those are substances. All right, and let's check out the video.
Do you have any idea what these three substances have in common? Ice, the solid form of water, helium gas, filling this balloon, and dry ice made of carbon dioxide. They are all pure substances. A pure substance is made up of one kind of material which has definite properties. It is the same throughout. Let us take salt, for example. Salt is a pure substance that has a definite square-shaped crystal. Salt has a white color and it has a salty taste. These are just a few of its properties. Many pure substances are made up of simple pure substances called elements. Aluminum is an element in this can. An element is a simple pure substance. An element cannot be changed into a simpler substance.
All right. Yep, elements are the basic beginning points. They cannot be broken down. All right, so heading back to here. So that's the end of that article. So activity 10 is just reading the article. There's nothing else that you need to do on activity 10. When you go to activity 11, this is the one where there's things for you to do. So on this one, as it's loading, they've given you this chart, and the chart has mass, it has temperature, and it has volume for 3 different materials. And all you're doing is reading these questions and choosing which one. So choose, or which one contains more matter than material 2? Well, remember, we just learned that matter is its mass. So which one has more matter than material 2? Everybody shout it out.
Material 1.
Material
Material 1.
Good.
Material
One. You guys see that? Material 2 is
1.
material 1 is 189. 189 is more than 1.
Yeah.
So you would put material 1. Okay. When you're finished with that, you hit submit, and then you're done with science for the day. Okay. So you are just responsible for 10 and 11 for science. Oh, I know what it was I wanted to talk to you guys about. I'm going to have you guys in just a minute. Hang on just a second. Let me take care of something.